These are the partial fractions that we were looking for. Okay, make sense? Now, the only complication was that it was in terms of a here. Okay, now it says, hence find the exact value of this integral, giving an answer in the form P ln Q plus R ln S, where P and R are integers and Q and S are prime numbers. Okay, now don't think too much about these conditions. Just find the integral and then we'll think about what to do at the end about this. Most likely it will automatically turn out to be something very close to this. We'll just have to do some minor changes. Okay, but let's see what we get from this. Integration of that expression from minus a to a. Now we've got three separate fractions. We can integrate all of them separately. 1 over 2a plus x. Let's integrate this separately. There are plus minus between them, right? We can integrate all of them separately. This is 9 over 2a minus x. Let's integrate this separately. And then finally, we have 16. There's a negative sign outside. Over 5a minus 2x. You need to integrate this as well. Limits for all of them are from minus a to plus a. Okay, now how do you integrate this? The first fraction, 2a plus x. What's the derivative of 2a plus x? It's 1, right? Remember, a is a constant. So 2a, the derivative of 2a is just 0. Derivative of x is 1. We already have 1 in the numerator, so this is the ln form. The integration of this becomes ln of 2a plus x. That's the first integration. Now, what about the second one? What's the derivative? Now, all of these are ln forms, right? We have x power 1 in the denominator, constant in the numerator. This is standard ln form. What's the derivative of 2a minus x? Derivative of 2a minus x is minus 1. We want minus 1 in the numerator. What we can do is we can say, first of all, let's write 9 outside. That leaves us with 1 over 2a minus x inside. We want minus 1 in the numerator. To get minus 1 in the numerator, we can say, let's put minus here. And to balance that, put minus outside as well. Make the sign minus as well. And now inside the integral, we've got the ln form, which we can integrate directly. Okay, so the integration of this is going to become minus 9 into ln of 2a minus x. What about the last one now? 5a minus 2x. What's the derivative of 5a minus 2x? Derivative of 5a is still 0. Derivative of minus 2x, that is minus 2. We want minus 2 in the numerator. Now for that, what we can do is, you can think of it like this. Let's write 16 outside first of all. Inside we're left with 1 over 5a minus 2x. What's the derivative of 5a minus 2x? Minus 2. We want minus 2 in the numerator. One way to think about this is we say, let's put minus 2 inside. To balance that, divide by minus 2 outside. Okay? Or if you can think of it directly, you can also say, take minus 2 common, take minus 8 common from this, and you would end up with minus 2 inside. But it's easier to think of it this way. Write the constant outside. And then since you want minus 2 in the numerator, you say, let's put minus 2 here. And to balance that, put minus 2 outside in the denominator. Okay? And now this is also ln form. Minus 16 over minus 2, that becomes plus 8. So we have plus 8. This is ln form. We can integrate this to ln of 5a minus 2x. And that's our integration done. Okay, so we're done with the integration part. Now it's about inputting the limits. Limits are from minus a to a. Let's input those limits and see what. Minus a to plus a. Okay, let's input a first of all. That gives us ln of 2a plus a minus 9 into ln of 2a minus a plus 8 into ln of 5a minus 2a. Subtract from this the case when you input x equal to minus a. That gives you ln of 2a minus a minus 9 into ln of 2a minus a, that becomes 2a plus a, plus 8 into ln of 5a minus 2 into minus a, that becomes plus 2 times a. Okay, you've input the limits here. Now simplify this. It becomes ln of 3a minus 9 ln a plus 8 ln 3a minus ln of a from here. Minus into minus, that becomes plus 9 ln of 3a. And then minus into plus 8, that's minus 8 ln of 7a. Okay, let's confirm this. This was 5a minus 2x. That gives us minus 2 into minus a. Yeah, that's okay. ln of 7a. This is what we're getting. Now, let's simplify this further. ln 3a, ln 3a, ln 3a. We can add and subtract these terms. 1 plus 8 plus 9, that is 18. I hope there are no careless errors here, right? What did we want in terms of q and s? They are integers. Q and s are prime numbers. Okay, can you spot any careless errors here? I think that's all right. Okay, let's write it as 18 ln 3a minus 9 and minus 1, that is minus 10 times ln a minus 8 ln of 7a. This is what we end up getting. Okay, after simplifying all of this, this is what we get at the end. Now what we need to do is we need to write it in this form. Now, we need to convert it to that form somehow. P ln q plus r ln s. How do we do that conversion? That's what we need to think about. Okay, yeah, so what we can do instead actually is we can break it down. This is 3a, this is 7a, right? So what we can do is we can use multiplication now to break it down, and that will have give us some terms in terms of a only. Yeah, so that's something that we can do here. We can say it's 18 into ln of 3a. What I'm doing is I'm breaking down ln of 3a into ln of 3 plus ln of a. I can do that, right? Multiplication law of logarithms. I've got multiplication inside log, addition outside log. And then I have minus 10 into ln of a here, minus 8. I could also write ln of 7a as ln of 7 plus ln of a. I could break it down into two parts like this. And now if I simplify this, it gives me 18 ln 3 plus 18 ln a minus 10 ln a minus 8 ln 7 minus 8 ln a, and there we have it. We get rid of the terms that have a in them, right? 18 minus 10 minus 8, that they get eliminated, and we're just left with 18 ln 3 minus 8 ln 7. And that's pretty much what we wanted. So they wanted P and R to be integers, 18 and 8, 18 and minus 8, that's all right. And then Q and S to be prime numbers, Q and S are prime numbers, 3 and 7 are prime numbers, and that's what we wanted, 18 ln 3 minus 8 ln 7. So that was actually the trick that you had to use here. ln of 3a and ln of 7a, we could break them down into ln 3 plus ln a and ln 7 plus ln a. And then the a terms get eliminated, and we're just left with this. That they expect you to find this argument by calculation, not by measurement. So that's not allowed. You can't do it by measurement. All right. Okay, let's move on to the next question. Now it says find the exact value of integration of x into x plus 1 divided by x squared plus 4. It's a fraction. Now, how do we integrate fractions? How do we integrate fractions? Now, remember the rules that we've got for fractions. ln rule. So you need to remember all of those rules. Now, let me just show that to you quickly as well. These are all the rules that we've got for integrating fractions. You need to remember them. Wait, I might go. Integration by, yeah. So these are all the rules that you have for fractions that you have to think of yourself. If it was a substitution, they will tell you it's a substitution. Otherwise, you have the ln rule. If numerator is the derivative of the denominator, you have the tan inverse rule, partial fractions. You have these two separate rules given in the formula sheet directly that you can use. Sometimes you can break the numerator like this. And sometimes if the fraction is improper, you have to do division and use quotient plus remainder over divisor. And then if none of those rules works, you take denominator to the numerator. You need to know all of these rules, all of these possibilities that can be there. Okay, make sure that you memorize all of those cases, that these are the different possibilities that you have for integrating fractions. Okay, so now when you get a problem like this, you would start thinking of them one by one. Does the ln rule work? Does this rule work? Does this rule work? Let's think about this. Does the ln rule work? Well, no. The derivative of the denominator is 2x. You can't have 2x in the denominator. That does not work. Is it the tan inverse form? Well, for tan inverse, you need a constant in the numerator. The denominator is tan inverse form, but in the numerator, you need a constant. You don't have a constant here, so that also does not work. You can't do partial fractions because it's x squared plus 4. If it was x squared minus 4, you could do partial fractions in that case. But in this case, you can't because x squared plus 4 cannot be factorized. All right, so none of those rules works. It's an improper fraction. So you could potentially use division to split it into two parts, quotient plus remainder over divisor. That could be one possible method that works here. However, in this case, it's worth exploring one of the other possibilities as well. If you expand it, let's see if it works. I'm not sure. Let's just try that. If we expand it, the numerator, that's going to give us x squared plus x divided by x squared plus 4 with respect to x. And now if you were to try splitting the numerator, let's just explore that possibility if that might work. X squared plus 4 over x squared plus 4. This could be integrated if we do that, but we can't do anything about this, right? We can't, yeah, we'll have to do long division anyway. Okay, so splitting the numerator does not work as well. So what we should do is we should do long division here. All right, it's an improper fraction. Sometimes splitting the numerator also helps. In this case, it does not help because this will not be integrated. Okay, we can't use tan inverse rule. That does not work. Tan inverse rule needs a constant in the numerator. You do not have a constant in the numerator. Okay, tan inverse rule does not work. It's an improper fraction. We have to do long division. Let's do division and see what we get from that. Okay, so we have x squared plus x. This needs to be divided by x squared plus 4. X term is missing. X term is missing. So it becomes x squared plus 0x plus 4. Okay, so for x term, you write 0x there. And now what do you multiply x squared by to get x squared? By 1. What do you get here? You get x squared plus 0x plus 4. Now let's subtract it. Change the signs. This becomes negative. This becomes negative. This also becomes negative. This gets cancelled. X comes down as it is. And you have minus 4 from here. And that's it. This is the remainder. This is the quotient. And now you could split it in. Let's raise your hand first, please, before speaking. Just give me a minute. X squared plus x over x squared plus 4. Once you're done with this, what you can do now is you can break it into two parts. Quotient plus remainder over divisor, right? So we've got this fraction. We could use that rule that you've done that you should know from polynomials. Dividend over divisor, that can be written as quotient plus remainder over the divisor. Okay, so what we can do is we can write this fraction like this. We can say this is dividend over divisor. We can write that as quotient, which is 1, plus remainder, which is x minus 4 over the divisor, which is x squared plus 4. So you split it into two parts like this, and then you think of how to integrate it after that. This is the first step that you have to do here. There's no other possibility in this case. Now, let me answer your questions one by one. So, Library, you're saying we could split it and then use tan inverse rule. That it still does not work because we would get x squared over x squared plus 4 plus 1 over x squared plus x over x squared plus 4. On the second one, ln rule could work. On the first one, nothing works. You will have to do long division on that anyway. Okay, so it would not work. Tan inverse would not work. Yes, Mustafa? Yes, we divide only once because you see we can't divide any further. What do you multiply x squared by to get x? Well, you can't. The process has stops here, right? Because the degree of the remainder is less than the degree of the divisor. So that's what we do in long division. We can't divide it any further. The process has to stop here, right? We can't go any further than this. Okay. All right. So it gets split into two parts like this. All right. What do we do now? One can be integrated directly. One integrates to x. What about this now? What's the derivative of the denominator? 2x. We want 2x in the numerator. If we wanted to use the ln rule, now we can't have 2x. So again, we think of all the possibilities that we have. ln rule is not working as of now, right? Tan inverse rule, again, does not work because we don't have a constant in the numerator. Partial fractions we can't do. However, now if we split the numerator, we could get something like this. Let me actually keep it like this for now, the whole thing. If I split the numerator now into two parts, I could write it like this. I could write it as x over x squared plus 4 minus 4 over x squared plus 4. And now each of these terms can be integrated separately. One can be integrated directly. On this, we could use the ln rule. On this, we could use the tan inverse rule because all of these forms are the standard forms now. So let's split them first into parts. This is the first integration. This is the second integration, x over x squared plus 4 with respect to x. And then the last one is 4 over x squared plus 4. Okay, so now we need to integrate each one of them separately. What about the first one? Integration of one is just x. This can be integrated using the ln rule, right? Why? Because what's the derivative of the denominator? Derivative of x squared plus 4 is 2x. We want 2x in the numerator. How can we get 2x in the numerator? We could multiply by 2 inside the integral, and outside we could divide by 2 to balance that. And now this part is following the ln rule. So this could be integrated like this. We could say this is 1 over 2 into ln of x squared plus 4. That's the integration of the second term. And now we think about this last term. You have a constant in the numerator, 2 terms in the denominator, 1 x squared term, plus a constant term. This is the standard tan inverse form. You can use tan inverse rule here. You could write 4 outside if you wanted. So you could perhaps write it like this, 4 outside, although it's not necessary, but that makes it easier to think of that rule as it's given in the formula sheet. Formula sheet says integration of 1 over x squared plus a squared. Integration of that is 1 over a into tan inverse of x over a. So we could convert it to that form. In the denominator, in place of x squared plus 4, we could write it as x squared plus 2 squared. And now it's exactly that form. In place of a, we've got 2. So now if you apply that rule, minus 4 outside remains as it is. Integration of this is 1 over a, which means 1 over 2, into tan inverse of x over a, that means x over 2. And that's the integration completed. Now we just need to input limits and find the exact value of this. This is what we get when we integrate this. Now we just have to input limits. Now let me know if there are any other questions on this. Is this whole process clear to everyone? Any confusion here? All right, good. So the integration part is done now. And now we can just input limits and see what that gives us. Okay, sorry, what happened there? Yeah. Okay, let's input 6. When we input 6, that gives us 6 plus 1 over 2 into ln of 6 squared plus 4 minus, this gets cancelled, we have 2 left here. So that's minus 2 into tan inverse of 6 over 2. All right, that's what we get when we input x equal to 6. Subtract from this the case when we input x equals 0 and see what that gives us. 0 plus 1 over 2 into ln of 0 squared plus 4 minus 2 into tan inverse of 0 over 2, that's a 0. Now let's simplify this. Remember, we want an exact answer at the end, so can't put the whole thing on our calculator. So it gives us 6 plus 1 over 2 into ln of 36 plus 4, that's ln of 40, minus 2 tan inverse of 3, minus 0 minus 1 over 2 into ln of 4 plus 2 tan inverse of 0. Tan inverse of 0 is also going to give you 0. So now you simplify this further. You've got 6 minus tan inverse of 3. I'm writing the ln terms together on purpose because in our final answer, we want to write down the ln terms as a single term. We can't have multiple ln terms in our final result. This is what we end up getting. And now we need to write this as a single ln term. We need to combine the two ln terms that we've got. How can we do that? I'm sorry, this was 2 tan inverse of 3. 6 minus 2 tan inverse of 3. Plus 1 over 4 ln 40 minus 1 over 2 ln 4. Right? That's what we're getting. How do we combine them as a single ln term? Ln terms divide, we can't do them right now because this is 1 over 4, this is 1 over 2. So we can't really do that. We need to get rid of these numbers that we've got outside. We've got 1 over 4 here, 1 over 4, 1 over 2 there. Remember, our final answer has to be written as a single ln term. Okay, these are multiple ln terms. How do we combine them? We can't use the division law right away. It was 1 over 2 ln 40, I'm sorry. So yeah, so I'm on a spree of careless errors recently. Okay, so this is what we get, 6 minus 2 into tan inverse of 3. It was 1 over 2, so that makes it easier actually, because I can take 1 over 2 common, and that leaves you with ln of 40 minus ln of 4. And now you can apply the division rule, the division law, because you've got 1 over 2 common outside. Inside, you've got ln 40 minus ln 4. You can use the division law now, and that gives you 6 minus 2 tan inverse of 3 plus 1 over 2 into ln of, this is subtraction outside log, inside log it becomes division. So it becomes ln of 40 over 4. And that is your final result, because now you can write it as 6 minus 2 into tan inverse of 3 plus 1 over 2 times ln of 10. Now this last step will have 1 mark. Converting the multiple ln terms to a single ln term, that is important. You need to do that. All right. Otherwise, you lose 1 mark. Even though they haven't written anything like this in the question here, they always expect your final answer to have a single ln term. If you have multiple ln terms, you need to convert them to a single ln term. That's important. Good. All right. Let's move on to the next one. Now it says find the exact area of the shaded region. Are giving your answer in simplified form. Okay. So how do you find this shaded region R now? So this is the shaded region. We have the function given, that's y equals sine x into cos of 2x. And yeah, so that's it. Let's find the shaded region. Y equals sine of x into cos of 2x. That's the function that we've got. What are the limits? We don't have the limits given either. Okay, so we'll need to find the limits as well, because it does not look like they've given us the limits. Yeah, they haven't. So we need to find these points first of all. Okay, because only then we can find this shaded region by integration. So how do you find these points? We have to put y equal to 0, right? Y equal to 0. Okay, so that's not going to be very difficult. Let's do that. Let's put y equal to 0 to find the limits. Let's see what we get from that. 0 equals sine x into cos of 2x. Now, since it's a product, we can put each one of these equal to 0 separately. So we get sine x equal to 0 or cos 2x equal to 0. Since it's a product, that means either the first thing is equal to 0 or the second thing is equal to 0. Now, what do we get from the first one? When is sine 0? Sine is 0 when x is equal to 0. But you can clearly see that's this point. That's not what we want. Okay, what's the next value after that? When is sine 0 again? It's 0 again at pi over 2. Okay. Think of the graph of sine. It's 0. It starts from 0 and then it becomes 0 again at pi over 2. Sorry, not pi over 2, pi. And then 2 pi, but 2 pi is going to be outside the interval. Yeah, so we only have values until pi. So sine is 0 at 0 and sine is 0 at pi, right? These are two values when sine is 0. And that's it, within that interval. When is cos 0? Cos starts from 1. It goes to 0 at pi over 2. So 2x could be equal to pi over 2. And then the next time cos is 0 is at 3 pi over 2, right? So that's outside the interval. These are the values that we're getting. X either equals 0 or pi, or 2x equals pi over 2. So from this, we get x equals pi over 4. These are the x-intercepts that we're getting. X equals 0, x equals pi, and x equals pi over 4. These are the three x-intercepts of this graph. This as well. Yeah, so we actually get another answer as well. So let me actually do it properly. Because cos of 2x equals 0, remember the interval for x was from 0 to pi, but here we've got 2 pi. So the interval for 2x is basically from 0 to 2 pi, right? Interval for 2x will be from 0 to 2 pi. So we can also consider when cos becomes 0 again. So first it's 0 here, that's pi over 4. Sorry, pi over 2. Then it becomes 0 again when it's 3 pi over 2. So for cos 2x equals 0, we actually get two results. Let me make some space here. Okay, let me repeat now. For cos starts at 1, right? Starts at 1 when x is 0. And then at pi over 2, it becomes 0. So that's one value that we're getting. But it becomes 0 again at 3 pi over 2. Since the interval for x was from 0 to pi, the interval for 2x would be from 0 to 2 pi. So we have to consider all possible angles until 2 pi. So this is also inside the range. 3 pi over 2, that's also inside the range. Now, if that's also inside the range, that means we have another possible value from this. That's 2x equals 3 pi over 2. And from this, we get x equals 3 pi over 4. So we have 4 x-intercepts that we're getting from this. 0, pi, pi over 4, and 3 pi over 4. Now keep them in mind. 0, pi, pi over 4, and 3 pi over 4. Let's represent them on that diagram. 0 is the smallest one. That's already shown here. Then the next one was pi over 4. That's here. Then the next one after that is 3 pi over 4. It's actually clear from the symmetry of the graph as well. You can actually figure it out using that as well. This is also 3 pi over 4. And then you have pi. So the limits are actually from pi over 4 to 3 pi over 4. All right, so these are what the limits are going to be for this integral. Does this make sense? Is this part clear? Any problems until this point? No? Limits again? We have just put y equal to 0. Okay, we put y equal to 0 and solved this. We got these 4 solutions. These are the x-intercepts of the graph. All right, these are the x-intercepts of the graph. We have 4 x-intercepts, which are 0, pi over 4, 3 pi over 4, and pi. Limits are these two, pi over 4 to 3 pi over 4. Right, these are the limits that we're going to be using here. Okay, now we need to integrate this, right? That's the next thing that we've got to do. We need to integrate this now. So we spent quite some time finding the limits, but now how do we integrate that? That's the next question. Let me make some space here. Okay. Now we need to find this area from pi over 4 to 3 pi over 4. So we need to integrate that function. Integration of sine x into cos of 2x with respect to x. How do we do this now? How do we do this integration for cos x and sine of 2x? Cos of sine x and cos of 2x. Now, one possibility could be to expand it, and if we expand it, what do we get from that? We get 1 minus 2 sine square, and that's going to give us, let me just think about it. One possibility could be that if we expand it, see if that helps, 1 minus 2 sine square x, and that would become sine x minus 2 sine cube x. And then you could do it using substitution, but that's something that you'll have to think of yourself then. Okay, so one possibility is this, that you yeah, we could do that. So that's what we could do. We could do integration by parts. That would also work. But for that, we'll have to use that loop thing. I'll explain what that means. Let me see if we could do something like this first. So if we have sine of x into 1 minus 2 sine cube x. Now integrating this actually requires substitution, right? So if you were to do it like this, you would have to use a substitution of sine cube x. If you remember, you have to use a substitution u equals cos x. So if you remember those substitutions that you've done for integrating odd powers of trigonometric functions, that's what you could use. Integrating odd powers, if you remember, for sine cube, you have to use the limit, use the substitution u equals cos x, and then it could be integrated pretty straightforward, in a pretty straightforward way. However, since they've not given a substitution, you would have to basically think about the substitution yourself. So that would require some thinking. So you could do that. For sine x will be integrated directly. Okay. For this, you could use a substitution u equals cos x, because you study how to integrate odd powers of sine separately in your course. I hope you've done that particular substitution. So if you remember that, you should actually remember that because you covered that in the course as well. This is what we get, sine x minus 2 sine cube x with respect to x. And now what's the integration of sine? Integration of sine is minus cos. And what about this now? Minus 2 into integration of sine cube x with respect to x. For this, you can use the substitution u equals cos of x. For sine cube, you use the substitution u equals cos x. For cos cube, you use the substitution u equals sine x. All right. Then just give me a minute. Let me just get done with this quickly. Sine x minus 2 sine cube x, that's what we get. We have to write on that side. Sine cube x, we use the substitution u equals cos x. What do you get from that? Du over dx, derivative of cos x is minus sine x. And now we make dx the subject, and that leaves us with minus du over sine x. Put that here. U equals cos x, and this. For using the substitution now, we'll have to split it into 2 parts. It becomes minus cos x minus 2 into integral of sine cube is going to be split into 2 parts like this. You would say this is sine square x into sine x with respect to x. And then sine square could be written as 1 minus cos square x into sine x with respect to x. And now you use that substitution, and that gives you minus cos x minus 2 into integral of 1 minus u squared into sine x into dx. In place of dx, we put that substitution du over sine x. And that gets these two terms cancelled, and you're just left with minus cos x minus 2 into integration of 1 minus u squared into minus, I could write this minus outside and make it plus. So 1 minus u squared into du, that's what you're left with inside. And now you can integrate this easily. Integration of 1 is going to be u, integration of u squared is going to be u cubed over 3. Now you put that substitution back, and that gives you minus cos x plus u was cos of x, and that gives you 2 into cos x minus cos cube x over 3. And that simplifies to minus cos x plus 2 cos x minus 2 cos cube x over 3. So this could be the other thing that you could use here, that you use a substitution. So this is something that you need to learn how to do, the integration of odd powers of sine. So generally what we do is integration of sine cube. For that, we use this substitution u equals cos x. For integration of cos cube, we use the integration u equals sine x. In this case of sine cube, we use the substitution u equals cos of x, and that gives us u equals cos x, du over dx equals minus sine x. You take dx, you make dx the subject, and that gives you minus du over sine x. You put that substitution here. I'm inputting u squared in place of cos squared, and then we put minus du over sine x in place of dx. Sine x and sine x get cancelled, and then we simplify this further. I've multiplied this minus outside, so it becomes positive here. And we have plus 2 into 1 minus u squared integration. Integration of 1 minus u squared would be u minus u cube over 3. Put that substitution back, you get cos of x minus cos cube x divided by 3. And this is what we end up getting at the end. That's cos of x minus 2 cos cube x over 3. That's the integral. Now you input the limits. What are the limits? Limits were from pi over 4 to 3 pi over 4. Let's input those limits. Pi over 4 to 3 pi over 4 and see what we get from that. Now you can try inputting the limits and see the result that we get from that. Okay, so let's input 3 pi over 4 first. That means cos of 3 pi over 4 minus 2 into cos 3 pi over 4 divided by 3. This needs to be cubed first, the numerator. So we could say it's cos of 3 pi over 4 whole cube divided by 3. Subtract from this the case when you input x equals pi over 4, and that gives you cos pi over 4 minus 2 into cos of pi over 4 whole cube divided by 3. Evaluate this and see what this gives you. You have to do it step by step. Since you want an exact answer at the end, it's minus 2. Are you talking about this, Laiva? What's minus 2? Which step are you talking about? Yeah, but what I did was I multiplied this minus outside to make it positive. We had that negative inside that had to be gotten rid of. So I just multiplied that outside. Okay. Okay, let's see what we get from that. Cos of 3 pi over 4. Let's put that in a calculator and see what that gives us. 3 pi over 4. That is giving me minus under root 2 over 2. Minus 2 into cos of 3 pi over 4 raised to power 3. Now it's only 4 marks. Let's not do that much effort on this. Let's do that directly. 2 into cos of 3 pi over 4 whole cube of that divided by 3. Okay, this thing is giving me plus under root 2 over 6. Okay, is that okay? Now, what does that give us? What does this give us? Cos of pi over 4. Cos of pi over 4. That's giving me under root 2 over 2. And then you have this thing. Let's see what that gives us. Minus 2 into cos of pi over 4 whole cube divided by 3. And that is minus under root 2 over 6. Let's see what we get from this now. Under root 2 over 6 plus under root 2 over 6. So that's going to give you 2 under root 2 over 6. These two terms are going to get cancelled, are they? Let's just put this on our calculator now. Minus under root 2 over 2 plus under root 2 over 6 it's very unfair question, by the way, plus under root 2 over 6 minus under root 2 over 2 plus under root 2 over 6. And that's giving me 2 under root 2 over 3. Yeah. So minus 2 under root 2 over 3. This is what I'm getting from this. And that is your final answer. However, since you were looking for area, this area was below the x-axis. We are getting a negative result because of that, because it's below the x-axis. When you write the area finally, you should write it as area equal to 2 under root 2 over 3. That's the area that you get from this. Okay, that's the area of the parallelogram. Any problems with this? Any questions, anyone? No problems? Okay, let's move on to the next question now. Question number 7. Okay, the variables x and y satisfy this differential equation where x is between 0 and pi over 4. It's given that y equals 0 when x equals pi over 6. You can use that later on to find the value of c. Solve the differential equation to obtain the value of x when y equals pi over 6. Give an answer for it. So first of all, we need to solve this differential equation. How do we solve the differential equation? We've got cos of 2x multiplied by dy over dx. That equals 4 into tan of 2x divided by sine square of 3y. Right? That's what the differential equation is. Now, how do you solve the differential equation? The first thing that you have to do is you have to separate the variables. We want y terms on the left side, dx will go to the other side, and x terms on the right side. Let's do that. Let's take dx to the right, and all the x terms to the right, all the y terms to the left. So this will come to the left, and it will become sine square 3y into dy. Cos 2x will go to the other side, and we would be left with 4 tan of 2x divided by cos of 2x and into dx. So that's the variables separated. We have separated the variables. That's the first thing that we had to do. We had to separate both the variables. All right. And now once we have separated the variables, now we need to integrate both sides. Integrate the left hand side with respect to y, integrate the right hand side with respect to x. How do you integrate sine square of 3y? Now, this is something that you need to remember. Even powers of sine, cos, and tan, they're integrated using trigonometric identities. For sine square and cos square, for both of them, you use the double angle identity for cos. What can we do for this? We can say we've got this double angle identity for cos. In the formula sheet, it's written like this: cos of 2a, that's identical to. We've got sine square, so use that form that has sine square. That's 1 minus 2 sine square a. That's the identity that we have for cos 2a. All right. Now we want sine square of 3y here. So in place of a, if we've got 3y, we want 3y here, right? Let's put 3y there on the right side. It becomes 1 minus 2 sine square of 3y. What would you have on the left side? On the left side, you have 2 times a. 2 times 3y, what does that become? 2 into 3y, that's 6y. So on the left side, you would have 6y. And now what you can do is you can make sine square 3y the subject, bring that to the left side, and that gives you 2 sine square 3y. That's identical to 1 minus cos of 6y, and then sine square 3y. That is identical to 1 minus cos 6y divided by 2. So on the left side, we can replace sine square of 3y with this thing. And that is 1 minus cos of 6y divided by 2. We need to integrate this with respect to y. Now, this is something that we can do directly. This denominator is a constant. We can write that outside, and that will become 1 over 2 into integration of 1 minus cos of 6y. And this can be integrated directly. We'll deal with the right side in a moment. This integration turns out to be integration of 1 with respect to y, that's y. Integration of cos of 6y with respect to y, that is going to be sine of 6y divided by 6. That's the integral that we end up getting on the left side. All right, let me repeat. This is a standard process that you need to know for integrating sine square and cos square. You always use the double angle identity for cos. For sine square, you use this form. Cos 2a equals 1 minus 2 sine square a. All right. We want sine square of 3y. In the identity, we've got sine square of a. So that means in place of a, we need 3 times y. All right. A needs to be replaced with 3y. So if a is replaced with 3y on the right side, what about the left side? On the left side, we've got 2 times a. That becomes 2 into 3y, that's 6y. And then we just make sine square 3y the subject, and that gives us this. So we can write sine square 3y as 1 minus cos of 6y divided by 2. And that's what we get. All right. And now this can be integrated because the power is eliminated now. Remember, we can't integrate sine 3y or whole raised to power 2 directly. We can't use power rule on this because for using the power rule, the part inside has a condition that has to be linear. We can't use power rule otherwise, right? In this case, the part inside is not linear. Sine is not a linear function. That's a curve. So we cannot use the power rule in this case. That will not work. Okay. So that's why we have to convert it to a form like this. Sine square needs to be converted to cos of 6y like this. All right. So that's the left side integrated. What about the right hand side? On the right hand side, we've got 4 into tan of 2x divided by cos of 2x. Now it's a fraction. How do we integrate fractions? Does any of the fraction rules work here? Well, you can think of them. ln rule, you don't have the derivative of the denominator in the numerator. Tan inverse, it's not that form. For that, you need constant in the numerator. Partial fractions you can't do, there are no factors. Splitting the numerator, again, you can't do. There's only one thing in the numerator. You can't split that. Quotient plus remainder over divisor method, that works for improper fractions. These are trigonometric functions. We can't use that. So none of those rules that we have for fractions, they work for an integral like this. What do we do then? If nothing else works, what we do is we take it to the numerator. When we take it to the numerator, we could write it as tan of 2x into cos of 2x whole power minus 1, and then think of using integration by parts, but that's going to make things very complicated because we've got one trigonometric function, another trigonometric function. We know that it does not get simplified, right? it would not become any simpler. So that's not going to work. What can we do instead? When we take cos to the numerator, it can be written like this. We can say this is 4 into tan of 2x into secant of 2x, right? Cos is the reciprocal of secant. So we can take cos to the numerator and write it as secant of 2x. And that's what we get. 4 into tan 2x into secant of 2x. This now needs to be integrated with respect to x. Now, how do you integrate it? Looking at this expression should remind you of something. Tan into secant. Have you seen this before? Let me show you the formula sheet. This is the formula sheet. In the integration rules, we don't have that function anywhere. Tan into secant. We can't see that anywhere here. Okay. However, in the differentiation rules, we see these three functions here. Derivative of tan is secant squared. Derivative of secant x is secant x tan x. Derivative of secant x is secant x tan x. From this, we get a reverse rule for integration as well. So it looks like this. Let me show that to you. I must have done that somewhere here. Integration. Integrating these functions. Yeah. So basically, using those differentiation rules that are given in the formula sheet, the derivative of secant x is secant x tan x. Derivative of cosecant is minus cosecant x cot x. Derivative of cot is minus cosecant square x. You can reverse those rules to say integration of secant x into tan x is secant x. Integration of this function is minus cosecant x, and integration of cosecant square is minus cot x. These are rules that you need to know about. Okay. These are the differentiation rules reversed. That's all that we've done here. Okay. Integration of secant x tan x is secant x. And in case you have some other expression in place of x, what do you do for that? You divide by the derivative of that, like you do for the other functions. If you have something other than x, a linear expression, you divide by the derivative of that. So how do you integrate this now? Let's go back to that. This was the function tan 2x into secant of 2x. We could rearrange it first to write it like this. We could say, first of all, write 4 outside. Inside, we're left with secant of 2x into tan of 2x. And now we know integration of secant x into tan x, that is basically supposed to be secant x. This is secant x, secant 2x into tan 2x. What's the integration of this going to be? This is going to be secant of 2x. However, since x is replaced with 2x now, we have to divide by the derivative of 2x. What's the derivative of 2x? It's 2. And that is the integration that we get on the right side. Okay. And now we can simplify this. On the left side, we get 1 over 2, or let's just multiply 1 over 2 inside, y over 2 minus 1 over 2 into y minus 1 over 12 into sine of 6y. On the right side, 4 and 2 get cancelled, and we're left with 2 secant 2x. That's the integration that we got on the right side plus c. And now what we can do is we can find the value of c and solve this differential equation. Okay. How do you find the value of c? You've got this point given. It says y equals 0 when x equals pi over 6. Let's input this point in this equation and see what that gives us. X equals pi over 6 and y equals 0. Let's put this here and see what that gives us. 1 over 2 into y, which is 0, minus 1 over 12 into sine of 6y, that's sine of 0, equals 2 secant of 2 times x. That means 2 pi over 6 plus c. That's what we've got. Okay. Now, on the left side, you've got 0. Sine 0 is also 0. That's also 0.
On the right side, we've got secant of pi over 3. Now, we don't have a secant button on our calculator. We have to write it as 2 over cos of pi over 3, first of all. What's cos of pi over 3? Cos of pi over 3 is 1 over 2. And the value of c turns out to be minus 4 from this, right? 2 will go to the numerator, it becomes 4. 4 goes to the other side, becomes minus 4. That's the value of c that we end up getting from this. All right. Now that we've got the value of c, now we can just put this back. In that function, what was the function? Write that here. 1 over 2 times pi minus 1 over 12 into sine of 6y. On the other side, you got 2 secant of 2x minus 4. That's what we've got. Okay, that's the function. And now we need to find the value of x when y equals pi over 6. So now we input y equal to pi over 6 and find the corresponding value of x for that. All right, let's do that. Let's put y equals pi over 6. What do we get from that? 1 over 2 into pi over 6 minus 1 over 12 into sine of 6 pi over 6. That equals 2 secant 2x. Let's write that in terms of cos. It will be 2 over cos of 2x minus 4. This is the equation that we now need to solve. How do we do that? 1 over 2 into pi over 6, that's pi over 12. Minus 1 over 12 into sine of pi. Sine of pi is 0, so this just becomes 0. On the right side, we've got 2 over cos of 2x minus 4. Now it's a trigonometric equation that we need to solve. This becomes 0. Let's take 4 to the other side. Do we need an exact answer at the end? No, we need an answer to correct 3 decimal places. Okay. So 4 goes to the other side. What is that going to become? 2 over cos of 2x. When 4 goes to the other side, that gives us pi over 12 plus 4, and that is 4.2618. Let's cross multiply. Cos 2x turns out to be 2 over this thing, which is 0.46929. All right, that's the value of cos 2x that we're given. Now, what was the interval that we were given? It says x is between 0 and pi over 4. Okay. X is between 0 and pi over 4. This is 2x. You can use a substitution if you want to do it, if you want to use that, or you can do it directly. What would be the interval for 2x? Interval for 2x would be until pi over 2, 0 to pi over 2. That means the first quadrant only. Let's find the basic angle. Cos alpha equals 0.46929. Remember, angle is supposed to be in radians. So when you do cos inverse, your calculator needs to be in radian mode. Cos inverse of 0.46929, and that's giving me 1.0823. Okay. Now we think of quadrants. Cos is positive, first quadrant or the fourth quadrant, however the interval tells us that it can only be the first quadrant. So this is the angle that we've got. That means 2x equals 1.0823, and the value of x therefore turns out to be this divided by 2. Correct to 3 decimal places, it would be 0.541, and that is what we were looking for. That's the value of x that we wanted.
It says by using integration by parts, show that for all a greater than 1, this integral is less than 1 over 9. Now, again, that's a question that's slightly different from what you normally see in past papers. Let's see how we're going to think about this. इसको पहले तो integrate करना है. अच्छा, इसको integrate करना है. तो okay, ठीक है. ऊपर first part तो कहीं पे use नहीं हो रहा. उसने क्या integration में parts use करना है, उसने आपको hint दे दिया already. So we have to use integration by parts. Integration by parts कब use करते हैं? When you got a product. So what we do here is we make it a product. इसको पहले आप इसको product form में लिखते हैं. How do you write this in product form? It's going to be ln x multiplied by x raised to power minus 4 dx. अब हमें क्या करना है? Integration by parts apply करना है. And we have to choose for that what we're going to take as u and what we're going to take as dv over dx. हमें पता है जब log आ जाता है और inverse या tan inverse आ जाता है तब तो हमें इसी को u लेना पड़ता है. But if you want, you can use that rule. I8 use कर लें, इसको देख लें. log left पर आ रहा है, algebraic function right पे आ रहा है, तो log को हम u लेंगे और algebraic function को dv over dx देंगे. ठीक है, ये हमारे पास आ गया. Let me write down the formula. The formula is integral of u into dv over dx with respect to x. That equals u into v minus integral of v du over dx with respect to x. ये इस तरह से फॉर्मूला शीट में दिया होता है. ठीक है, अब सबसे पहले हमने चूज कर लिया कि हमें u क्या लेना है और dv over dx क्या लेना है. So we know ln x को हमने क्या ले लेना है यहाँ पे u और इसको हमने ले लेना है dv over dx. And we discussed the reason for that. I8 आप यूज कर लें, उससे आपके पास आ गया. अच्छा, now let's apply the formula. Let's apply the formula on this. उससे पहले in fact let's write down these values separately. u पहले लिख लें साइड पे. u क्या है? ln x. du over dx क्या हो जाएगा? It's going to be 1 over x. You've got dv over dx. What is that? That is x raised to power minus 4. इसका इंटीग्रल क्या हो जाएगा? v x raised to power minus 4 plus 1, which is minus 3 divided by minus 3. And that gives you minus 1 over 3 x raised to power minus 3. ये आपके पास आ गई. ये चीजें आपको चाहिए. u चाहिए, du over dx चाहिए और आपको यहाँ से v चाहिए. These are the things that you're going to input in the formula. ठीक है, अब फॉर्मूला में क्या था हमारे पास? I'm going to write that here again. We've got uv minus integral of v du over dx with respect to x. ये लिमिट्स बाद में एंड पे जाके देखें. अभी let's just evaluate this first. u times v, that's going to be ln x into v is minus 1 over 3 x raised to power minus 3. We subtract from this integral of v. Again, what's v? v is minus 1 over 3 x raised to power minus 3 into du over dx. That is 1 over x with respect to x. Okay, what does that give us now? 1 over 3, इसको हम इस तरह लिख लेते हैं. 3x cube नीचे आ गया into ln x. Let's take the constant outside. ये क्या हो गया? plus 1 over 3. Constant multiply हो रहा होता है, उसको हम इंटीग्रल के बाहर लिख सकते हैं for simplifying things. अंदर क्या बच गया हमारे पास? This is x raised to power minus 3. This will go to the denominator, या फिर नीचे वाले x को इनफैक्ट ऊपर ले आए. We will get x raised to power minus 4 with respect to x. अब इसको इंटीग्रेट कर लेंगे. इसको इंटीग्रेट करेंगे तो हमें क्या मिलेगा? We will get plus 1 over 3 into x raised to power minus 3 divided by minus 3. And now we've got to input the limits. एक दफा और थोड़ा सा और सिंप्लीफाई कर लेते हैं before we actually input the limits. Minus 1 over 3x square ln x minus 1 over 9 x cube. That is what the integral turns out to be. ये आपकी इंटीग्रेशन कंप्लीट होगी इस पॉइंट के ऊपर. अब सिंपली क्या करना है आपको वो लिमिट्स इसके अंदर इनपुट कर देनी. Now what are the limits? Limits are from 1 to a. 1 to a limits input कर दें. What does that give us? That gives us 1 over 3 a square into ln of a minus 1 over 9a cube. Subtract from that the case when you input 1, that gives you minus 1 over 3 into ln of 1 वो 0 हो जाएगा. minus 1 over 9. And now you simplify this thing. That's going to give you minus 1 over 3a square into ln of a. Was it 3a square or cube? Okay, I'm sorry. This was actually supposed to be a cube here. यहाँ पे ऊपर से cube चला रहा था. I changed that to square. Yeah, minus 1 over 9a cube. ये तो 0 होगी टर्म. ln 1 0 होता है. Minus into minus 1 over 9, that's going to give us plus 1 over 9. This is the integral that we end up getting. You can write it like this. 1 over 9 minus 1 over 3a cube into ln of a minus 1 over 9a cube. This is the value of that integral that we end up getting eventually. ठीक है? ये हमारे पास वो integration आ गई उसकी. Now, how do we argue that this is less than 1 over 9? How do we argue that this is less than 1 over 9? अब देखें, अब जब आपके पास ये स्टेटमेंट आ गई n पे, अब देखें 1 over 9 तो ये आ रहे हैं यहाँ पे, है ना? अब इसमें से कोई चीज माइनस कर रहे हैं, इसमें से कोई चीज माइनस कर रहे हैं, 1 over 9 में से कोई चीज माइनस कर रहे हैं. If we can somehow prove that this thing and this thing, both of them are positive, that will be enough to prove कि ये पूरा एक्सप्रेशन 1 over 9 से छोटा है. Because 1 over 9 में से कोई पॉजिटिव चीज माइनस करेंगे तो हमारे पास result 1 over 9 से छोटा होएगा. In fact, it's going to be easier to understand if you write it like this. अगर आप माइनस कॉमन ले लें यहाँ पे, अंदर के आगे आपके पास 1 over 3a cube ln a plus 1 over 9a cube. ये आपके पास अंदर लिखा हुआ. You've got to prove somehow that this thing is positive. अगर ये अंदर वाली चीज पॉजिटिव है तो आपके पास ओवरऑल रिजल्ट 1 over 9 से छोटा आएगा, बिकॉज आप 1 over 9 में से कोई चीज माइनस कर रहे हैं. ठीक है? हाउ डू यू प्रूव दिस? उसने आपको क्या दिया हुआ है? उसने आपको दिया हुआ है a की वैल्यू जो है वो ग्रेटर देन 1 है, यानी a एक तो पॉजिटिव है और 1 से भी बड़ा है. When a is greater than 1, that basically means ये टर्म पॉजिटिव होएगी. 1 over 3a cube पॉजिटिव होएगा, राइट? बिकॉज a पॉजिटिव है तो ये टर्म पॉजिटिव है. ln a भी पॉजिटिव होएगा. Why? Because यहाँ इसके लिए a का 1 से बड़ा होना जरूरी था. ln of a number that's greater than 1, that is positive. 1 से छोटे नंबर्स का ln लेना वो नेगेटिव आता है. So इसलिए इसका 1 से बड़ा होना जरूरी था. 1 से बड़ा होगा, a की वैल्यू 1 से बड़ी होगी तो ln of a आपका पॉजिटिव आएगा. और 1 over 9a cube, अगेन अगर a पॉजिटिव है तो ये भी पॉजिटिव होएगा. ठीक है? So आप क्या कहोगे? 1 over 9 less than something positive, the result is going to be, this gives us something that is less than 1 over 9. ये minus 1 over 9 से छोटा नंबर होएगा. That's what you can argue here. कि 1 over 9 में से कोई पॉजिटिव नंबर हम माइनस कर रहे हैं. 1 over 9 में से कोई पॉजिटिव नंबर माइनस करेंगे तो रिजल्ट जो है वो 1 over 9 से छोटा आएगा. So that's why that given statement is justified. वो जो ऊपर हमारे पास रिजल्ट था, ln of x over x raised to power 4 with limits 1 to a, that should be less than 1 over 9 for this reason.
Okay. Question number 10. Let's try this one. Now it says the diagram shows the curve y equals under root x into cos of x.
For x between 0 and 3 pi over 2, and its minimum point m. Okay, so you've got the curve. Interval is from 0 to 3 pi over 2. Minimum point is m. You can see that in the diagram as well. X is a, m is when x is a. Show that a satisfies this equation. Tan a equals 1 over 2a. At a, you've got the turning point. How do you find turning point of a function? You find the derivative, put that equal to 0. So find the derivative of this function. You can write this function as y equals x raised to the power 1 over 2 into cos of x. Now, when you differentiate it, you have to use the product rule. X raised to the power 1 over 2 as it is, derivative of cos is minus sine, plus cos x as it is into derivative of x raised to the power 1 over 2, which is 1 over 2 into x raised to the power minus 1 over 2. Put this equal to 0. And you know, when the derivative is 0, the value of x is supposed to be a. So you put dy over dx equal to 0. So when you say when x equals a, dy over dx is equal to 0. And you get an equation like this. I'm not sure why they've given such little space for this. Okay, so this is what we get. We say 0 equals minus x raised to the power 1 over 2 into sine of x plus, or in fact, in place of x, we've already input a, so it becomes minus a raised to the power 1 over 2 into sine of a plus 1 over 2. I can write this x in the denominator with positive power, x power 1 over 2 into cos of x. Again, it should be a instead of x, to a raised to the power 1 over 2 and cos of a in the numerator. Make sense? So derivative is 0. In place of x, I've input a. Now let's simplify this. Multiply the whole equation by 2a raised to the power 1 over 2 to get rid of the fraction. Let's do that. If I multiply the whole equation by 2a raised to the power 1 over 2, it becomes minus 2a, a raised to the power 1 over 2 into a raised to the power 1 over 2, that becomes a, sine of a plus cos of a equals 0, and that becomes 2a sine a equals cos of a, sine over cos, sine a over cos a, that becomes 1 over 2a, and tan of a equals 1 over 2a. That's what you had to prove in the first part here. Okay, tan a equals 1 over 2a. That's the first part. Now the second part is just using this iterative formula. You can do that, right? Make sure your calculator is in radian mode. And yeah, just use the iterative formula. Iterations should be rounded off to 4 decimal places. Final answer should be rounded off to 2 decimal places. The last decimal should be properly rounded off. Make sure that you take care of that, okay? Let's do the last part of this. It says, find the volume of the solid obtained when the region R is rotated completely about the x-axis. Give your answer in terms of pi. Now, what's the formula for volume of revolution about x-axis? Pi into integral of y squared with respect to x. Limits are values of x. X equals a to x equals b. We need to find this volume of revolution. Okay, now for that, we need the value of, or no, we don't need that. Sorry. We need the limits for this. This is 0. What about the upper limit? This is the x-intercept of the curve. Let's find that upper limit on the side here. Y equals under root x into cos of x. Put y equal to 0 to find the limits. 0 equals under root x into cos of x. That means either under root x equals 0 or cos of x equals 0. You get x equals 0, you already know that. Cos x equals 0. Now, this is the first answer that you have in the on the positive side. When is cos first equal to 0? Cos is first equal to 0 at pi over 2, right? Yeah, so this is pi over 2. Think of the graph. This is what the graph looks like, right? This is 0 when x is pi over 2. So the limit that you've got here is pi over 2. And that makes visual sense as well. If this is pi over 2, this is 3 pi over 2, that's okay. All right. So this is the limit. You've got the limits now. Now you find y square. Okay, what is y square going to be? Okay, let's evaluate y square on the side here first. Y square equals x cos square x, right? That is what y square is. We need to integrate this and input those limits. Vx is pi into integral of x into cos square x with respect to x. Limits are from 0 to pi over 2. This is what we want to evaluate. And now it's an integration problem. We have to integrate x squared into cos of x into cos square x. Now, how do you do this? It's a product. How do you integrate products? You have to use integration by parts. Okay. How do you use integration by parts here? Which two functions do you have? You have an algebraic function and a trigonometric function. Let's use ILATE, ILATE. The one on the left should be u, the one on the right should be v dash. You've got algebraic and trigonometric. Trigonometric should be taken as v dash and x should be taken as u. Okay. Now before that, should we actually simplify this first or simplify that later? Let me think about it. If we simplify it first using that identity, cos 2a, that is 2 cos square a minus 1, we get cos square a identical to 1 plus cos 2a over 2. If we put this first, we would have half of that, and then x into that thing, we would get rid of the square. Otherwise, we would have this thing and that integrated. Cos square x. Okay, it doesn't make much difference. You can either apply this identity first, or you can apply it after using integration by parts. It would not make any difference. Sorry, x square cos square x. No, it's x cos square x because we have under root x here, right? Under root x squared, that is just x. That's not x squared. Okay. All right. Okay, so we can do it either way, apply integration by parts first and then that identity, or apply that identity first and then use integration by parts. Both are going to work. Okay, and there's not much difference in the number of steps you have to do. Let's use integration by parts directly. Integration of uv dash, that is given by uv minus integration of vu dash. U is x. I'm going to do that calculation here on the side. U is x. Let's write that here. U is x. V dash is cos square x. What's u dash? That is 1. What is v going to be? What's the integration of this? For integrating this, we should first write this in that form. What does that become? Using this, 1 plus cos 2x divided by 2. I'm going to break it down into two parts like this. 1 over 2 separately, and then half cos 2x over 2 separately. Half into cos 2x separately, right? It's the same thing as this. Now, let's integrate it. Integration of 1 over 2 is 1 over 2x, and integration of cos 2x is sine of 2x divided by 2. And that gives us 1 over 2x plus 1 over 4 into sine of 2x. That's the value of v that we get. Okay, so we have u, we have v, we have u dash and v dash. Now we just input this in the formula, pi into uv minus integration of vu dash, right? That's what it is. U as it is, that means x as it is, into v. What's v? V is this thing. Half x plus 1 over 4 into sine of 2x minus integration of vu dash. V as it is, which is 1 over 2x plus 1 over 4 into sine of 2x, integration of this, into u dash. What's u dash? U dash is just 1. So that's just 1 into dx. Now we need to integrate this thing. And this whole thing is, of course, multiplied by pi outside. Limits are from 0 to pi over 2. Now let's simplify this further. This gives us pi into 1 over 2x squared plus 1 over 4x into sine of 2x minus integration of half x squared over 2, right? Half remains as it is. Integration of x is x squared over 2. Let me have the negative sign as it is for now. Yeah, let me have it like this for now. And then what's the integration of this? 1 over 4 remains as it is into integration of sine. Integral of sine is minus cos. So it becomes minus cos 2x divided by 2. Okay, now let's simplify this further. It becomes 1 over 2x squared plus 1 over 4 into x into sine of 2x minus 1 over 4. Now integration is done, right? 1 minus 1 over 4x squared. And then minus, that becomes plus 1 over 8 into cos of 2x. Now, one last step before we input the limits, we can actually simplify this. Half minus 1 over 4, that's 1 over 4, right? So it becomes 1 over 4x squared plus 1 over 4x into sine of 2x plus 1 over 8 into cos of 2x. Now we input the limits. Limits are supposed to be from 0 to pi over 2. Input pi over 2 first of all. Pi remains outside as it is. Input pi over 2, that gives us 1 over 4 into pi over 2 whole squared plus 1 over 4 into pi over 2 into sine of 2 pi over 2 plus 1 over 8 into cos of 2 pi over 2. Subtract from this the case when you input x equal to 0. When you input x equal to 0, this first term becomes 0. This term also becomes 0. What are we left with? 0 plus 0 plus 1 over 8 into cos of 0. Okay, now let's simplify this further. This gives us pi into 1 over 16 pi squared. You want an exact answer, right? Yeah, in terms of pi, 1 over 16 pi squared plus 1 over 8. Okay, what's sine pi over 2? Sine 2 pi over 2, sine pi is 0. So this second term actually becomes 0. Right, this also, all of this becomes 0. Why? Because sine of pi is 0. Now what about this term? Cos of pi. Cos of pi is minus 1. Do that on your calculator, right? Cos of pi is going to give you minus 1. And then minus this thing, 1 over 8 into cos of 0. What's cos of 0? Cos of 0 is 1. And that gives us pi into 1 over 16 pi squared minus 1 over 8, that will be minus 1 over 4. And this ends up being 1 over 16 into pi cube minus 1 over 4 times pi. That is the result that we get from this.